topic is mass spectrometry technique. Okay, so what is the meaning of mass spectrometry? Now, mass spectrometry is an analytical tool that measures molecular weight of the compound. That is very important terminology, because a molecular weight serves a very important tool to recognize a compound. Okay, now how to determine this molecular weight, let us discuss in the principle of mass spectrometric technique. Now, the ionization is the most important steps of mass spectrometric technique, where a molecule can convert it into the molecular ion. Now, what is the meaning of this? Now, whenever you have a molecule, if you impact them with a higher than its ionization potential, then it can form a cation and it dislodges the 2 electrons, right? But whenever you impact the molecule with lesser than its ionization potential, like around 70 electrovolt, then it can dislodge only 1 electron than both the electrons. So this makes the molecule very unstable, and it can undergo the fragmentation process and can be detected by the mass spectrometric technique by the help of a Faraday collector. Okay, it's a detector. Now, if you observe, this is a double focusing mass spectrometer, where we are introducing a sample. Okay, this is an ionization chamber, ion source, where tungsten filament, dropping the electron, and the anode is attracting that electron and creating an electron flux in this particular process. Now, when the molecule is introduced, it is going through this electron bombardment or electron impact. Okay, and it can form a radical cation or molecular ion, or sometimes it's called as parent ions. Okay, so this parent ion can undergo fragmentation process, which can be like either it can be form another molecular ion and a neutral ion, or it can form a cation and a radical. One thing you must remember, in mass spectrometric technique, the neutral ion cannot be detected. The ion without the charge cannot be detected. Why so? Because in mass spectrometric technique, the various ions are separated as per their mass to charge ratio. Okay, as per their mass to charge ratio. So suppose I have used this molecule introducing the mass spectrometer. Okay, so what happened? The ethanol, if you see, if I go for electron impact, okay, then one of the loosely bound electron should get dislodged. So there are 4 non-bonded electron, and 1 electron get dislodged. So there are the order of dislodgement of electron. N electron will be dislodged faster than pi, and the sigma is the later, because sigma electron is more strongly bound electron. So over here, if you see, the 1 electron gets dislodged and it form a molecular ion or parent ion, whose mass by charge ratio can be detected as 46. Over here I have plot a mass spectrum graph, which is relative abundance and the mass by charge ratio. Remember, relative abundance is nothing but the duration of the time is get detected in the detector. So that means the mass fragments or the molecular ion or the parent ion or any fragments which possess M by Z ratio or mass by charge ratio, if they are more stable, they detect for the longer time, and their relative abundance also goes high. Okay, so 46 is the parent ion, and we see that with the help of alpha fission, it's one of the fragmentation process. It generates CH3 dot and CH2 double bond O, 2 electron plus H, 1 cation. If you see, I have just discussed over here, 1 radical, 1 cation, or 1 radical cation, and another one is electrically neutral, without any charge molecule. So these 3 fragments can be detected. This is 15. Over here I mentioned this is 31. Now, why this is more stable? If you see, if the electron goes on the oxygen, then this becomes CH2 plus. So the carbocation over here formed is more stable than the radical cation. Okay, so that's why if you see radical cation, of course they are the next stable molecule after the cation, and the radical is the least stable molecule. Okay, so that's why the 15 coming over here. So highest abundance of mass spectra, we call them base peak, is known as base peak. Okay, and this is known as parent peak. So like that you get mass spectrum. Okay, but these ions has to be separated properly during the mass spectrometric analysis, and that's why we use both the field over here, electrostatic field and the magnetic field. This mass spectrometer known as double focusing mass spectrometer. So let us discuss the working of it. The kinetic energy of an ion of a mass m. So if you see that one of the molecule, so if it gets fragmentized of m1 plus or m2 dot, so it's having a molecular mass m. Okay, so the kinetic energy of an ion of a mass m traveling with the velocity v is generated by the energy half is equal to E is equal to half mv square. Okay, when molecular ion enters to electrostatic field and got repelled by a voltage V, so potential energy become ZV, which converted into kinetic energy half mv square during its journey in the electrostatic field, because electrostatic fields is repelling the molecule for the linear velocity, that is ZV potential energy, and it converted into the kinetic energy. And after that, so what happened if we only generate the linear velocity? The molecules will be so close, the fragments will be so close, we cannot detect them properly with a proper resolution. So that's why we generate a magnetic field where the linear motion trapped into the circulatory motion, and this circulatory motion enable a molecule and the fragments to be detected in a more easier fashion, or in a more separated way. So that's why this half mv square, that ZV, whatever the energy, we convert them into ZBV. B is a magnetic field strength, and then the circulatory motion, it is centrifugal force mv square upon r. This is centripetal force, this is centrifugal force. With this particular equation, we can deduce the m by z ratio of the compound, that is m by z is equal to b square r square upon 2v. So by the help of this method, we can find out the molecular mass of each fragment, and you can determine, you can say that this is the molecule known as ethanol. Okay, so in a similar way, if you see that the mass analyzer, we have different type of mass analyzer. One mass analyzer known as quadrupole mass analyzer, where we are placing electrostatic field only with 90 degree to each other. There are 4 electrostatic field, so that they get a sufficient amount of time before reaching to the detectors. Okay, over here it is all the electrostatic fields are arranged 90 degree parallel to each other. Then we have another mass analyzer known as time of flight, where instead of velocity they detect the time, that is distance upon time. So this time of flight is